This is the introduction to section 4.7, part 2, and we're talking about overlapping triangles and being able to prove more than one set of triangles congruent to each other. Okay, so in the proof, what I've done so far, as you'll notice, is I have separated the triangles that we have, the pairs of triangles that we have that looks the same. Okay, so I've taken triangle ACD and put it here. And I've taken triangle BCD and put it here. Those two triangles look similar. They look the same. And then I've also taken triangle AEC, which is here, and triangle BED, which is here, and put them down as well. Okay? Now, as we start out here, you'll notice in the given, they give us that the triangles are congruent. And this is something different because we've never had the triangles congruent in the given. So, as I mark this guy down, I know that that's my given. Now, that's important because triangle ACD and triangle BCD are congruent, which is these two triangles right here. Okay? These two triangles. And if those two triangles are congruent, that's going to give you something. That means that all the corresponding sides and angles are congruent as well. So this side is congruent to that side. These two sides are congruent. And these two sides are congruent. Okay? And then we also know that all these angles are congruent to each other that are in corresponding positions. So now that applies here because there's some important things that matter in here as well. And if you look at eventually, we want to prove that CE is congruent to DE. Now, if you look in these two triangles, CE and DE don't exist. So we're going to have to use the other triangles. We're going to have to prove the other triangles congruent in order to prove that. So now, as I move this down here, what we need to figure out is what angles, or sides for that matter, are exactly the same in the two triangles, okay, that we have marked. Well, as you look here on these two things, you can tell that first of all, we know that AC and BD were marked congruent in the up above. And we can also see that angle B and angle A are congruent in the up above as well. Now that's going to be my first step. I'm going to be able to say that angle A is congruent to angle B. And I also know that AC is congruent to BD. And how do I know that? Well, I know that because corresponding parts of congruent triangles are congruent. Those two things were in the two triangles that I just proved to be congruent. Okay? So now, if I go back and look at my bottom triangles, right now I have an angle and a side, and an angle and a side. And if you'll look at the picture up above, you'll notice you have vertical angles right here. So if I were to say that these two angles are now congruent by vertical angles, I could then say the triangles are congruent by angle, angle, side, and angle, angle, side. So that's what I'm going to look at now. I said angle AEC is congruent to angle BED, which are the two verticals. Vertical angles are congruent. Okay, so now I know that those are congruent. Now I can say that triangle AEC is congruent to triangle BED by angle, angle, side. And then I can say CE and DE, which if you look, are CE and DE in this triangle? Sure they are. Here's CE, here's DE. Those are in those triangles. And those two would be congruent by corresponding parts of congruent triangles are congruent. Okay? So, as we look at this example, again, I'll zoom back out here. And there's an example of our first proof. Okay? Okay, now I'm going to move you to the bottom proof here. Okay, because the bottom proof is a little bit more extensive as we look at this picture here. Okay, and we're going to take the top proof, and we'll do the top proof in class to start tomorrow. Okay, so first thing I need to do is I need to figure out, okay, what triangles do I have in here that look like they're congruent? Well, I'm going to start with BAE. And then I also have DAE. Okay, that's this triangle here and this triangle here. Okay, I also know that I have two of the smaller triangles. I've got triangle BXA and I've got triangle DXE. Okay. Now, in the given, it says CA is congruent to CE, and it says that BA is congruent to DE. So I'm going to mark this on this right here. BA is congruent to DE, and essentially I've got BA here and DE here as well. Okay, those are in my given. All right, now, first thing we're going to look at here, okay, is that CA and CE are congruent. And if you look at where CA and CE are, CA is this whole left side, and CE is this whole right side. So if the two sides are congruent, that means we have an isosceles triangle, which also means that the base angles are congruent as well. So my first step in this case is going to be that this angle right here, this whole angle, and this whole angle are congruent to each other, which, if you'll notice, it happens to be this angle here and this angle here. Now, I'm going to name them so that it matches up to my triangles. So when I name this, I'm not going to name it CAE and CEA, but I am going to name this BAE, angle BAE, and it doesn't really matter if it's CAE or BAE, is congruent to angle DAE. And my reason is converse of the isosceles triangle theorem. Okay, so now I need to mark this in my pictures. That's this angle and this angle. The big angles, D, or the big angle A and the big angle E. Okay, well, as you look at the picture, you'll notice they also share a side. So my next step is going to be that AE and AE are congruent. So as I look now, here, I've got AE is going to be congruent to AE, and this is by the reflexive property. Okay? And now again, if you look back here at your triangles, these triangles here, can I prove that these triangles are congruent? Sure. I've got side, angle, side. Side, angle, side. So, I can say next that triangle BAE is congruent to triangle DAE, or sorry, not DAE, it would be DEA. Okay, triangle BAE and triangle DEA. Okay, and the reason that they are congruent is because of side, angle, side. Okay, now, the key now is to be able to match up sides or angles that happen to be the same as the ones that are in the bottom. So if I know that these two triangles are congruent, I know now all their corresponding sides and angles are congruent as well. So I know that angle B and angle D are congruent, essentially. Okay, but I can't name it angle B and angle D because I'm on the whole picture. I've got to be able to be a little bit more specific. So I'm going to name it angle we're going to go angle ABX is congruent to angle XDE. Yep, XDE, which essentially is angle B and angle X, which is right here, or angle B and angle D, which is right here and right here. Okay, and I know that by CPCTC. Okay, I know that by CPCTC. So now, again, as I look here at my triangles, I can mark those down. I've got an angle and I've got a side. Okay, and now I also remember have vertical angles as well, because if you look again at this main picture, these two angles right here are vertical angles. So I can say now that angle BXA is congruent to angle DXE, and my reason is vertical angles are congruent. So now I come down and I mark that as well. These two guys are congruent to each other. And now I can say that these two triangles are congruent by I can say that now triangle ABX is congruent to triangle EDX by angle side. And now as you look at your what the part that they want you to prove, BX and DX, here's BX, here's DX. So BX is congruent to DX by CPCTC. Okay. Now that's definitely as long as any proof as you're going to see. Okay. And yes, these are kind of challenging, so it's important to study these. So this concludes section 4.7, part 2. And make sure you complete the WSQ when you're finished.